Hello, 12th standard students. Welcome back to chapter 4, inverse trigonometric functions. Today we are going to see the tan function y equal to tan x, and here they are given for us the domain of the tangent is given, and you will understand why it is so as we go into the session. Okay, the range is minus infinity to infinity, and the tangent function is y equal to tan x with a period of pi. Okay, a graph they have drawn between x belongs to minus pi by 2 and pi by 2, and here when you see in this tabular column here for 90 pi by 2 it is not, tan x is not defined. Similarly 270 it is not defined. So pi by 2 or minus pi by 2 or 3 pi by 2 or minus 3 pi by 2, you will get it as infinity. Okay, not defined. Okay, so according to that you have to write the sign also. So here in the graph they have given minus pi by 2 to pi by 2. Minus pi by 2 you will get minus infinity, and pi by 2 you will get infinity. And when you plot there, you will get a vertical line along the pi by 2 or minus pi by 2. That is called as the asymptote. Okay, vertical asymptote. So what is the graph? So it is between minus pi by 2 less than x less than pi by 2, and the interval minus pi by 2 is called as a principal domain. Okay, and then the graph, it's seen that y equal to tan x is positive for 0 less than x less than pi by 2, and negative when pi less than x less than 3 pi by 2, and it is negative. So 2 interval it is positive, and for 2 interval it is negative. Okay, now properties of the tangent function. So the graph is not continuous, it has a discontinuous point at x equal to 2n plus 1 pi by 2, odd numbers of pi by 2. Okay, pi by 2, 3 pi by 2, so on. Okay, where n belongs to z. Okay, and the partial graph is symmetric about the origin, whereas the graph you have drawn between pi by 2 and pi by 2, it passes through the origin, so it is symmetric about the origin between minus pi by 2 and pi by 2, and as definitely many vertical asymptotes. Okay, and neither maximum nor minimum, and this goes through one complete cycle. So its period is pi by modulus of b, and it has not got amplitude because it has got no maximum or no minimum, so we cannot say it has got amplitude. What about the inverse function? So inverse function is going to be the vice versa. Whatever comes in x will come in y axis, and whatever comes in the y axis will come in the x axis. According to that, here tan inverse function is a unique number y in minus pi by 2 to pi by 2, denoted by tan y equal to x. In other words, tan inverse is from minus infinity to infinity to minus pi by 2 to pi by 2. Okay, and what about this? Only if it is minus pi by 2 less than y less than pi by 2, and for any real number y tan inverse is an odd function. Remember this, and note that tan inverse of tan x equal to 0 and not pi. Okay, whenever we talk about the inverse tangent function, tan is minus pi by 2 comma pi by 2 to r, whereas tan inverse is r to minus pi by 2 pi by 2, and the restricted domain minus pi by 2 is called as the principal domain, and the values to x belonging to r is called the principal values of the function y equal to tan x. And here is the graph for you. So it also passes through the origin, so the graph passes over, so it is symmetric with respect to the origin, hence y equal to tan inverse is an odd function. Okay, both are odd function because they are symmetric about the origin. Whichever graph is symmetric about the origin is odd function. Okay, so with this basic properties and definition of the tan x and the tan inverse x, we can go into our examples and problems. Okay, thank you.